Okay guys, here's my final math video for today. I'm kind of exhausted. I also did the 7th graders, so bear with me please. This is problem set 33. You have GO of 2, 28, and 30 today, okay? Alright, this is actually a really fun lesson. I like doing prime factorization, and I think you'll find that it's rather easy, okay? And that'll be a nice break for you guys. Alright, first of all, we need to review what a prime number is. Recall that a prime number is any number that can only be divided by one end itself, by nothing else. That means 1 is not prime because 1 can only be divided by 1. So it's not a prime number. The opposite of a prime number is what we call a composite number. So a composite number can be divided by more than 2 numbers. So the number itself plus another number. Okay? So for example, the number 2 can only be divided by 2 and 1. So therefore it is prime. The number 3 can only be divided by 1 and 3. So it's prime. The number 4 though can be divided by 2, by 4, and by 1. So it is not prime, it is composite. Now let's consider the number 1. 1 can only be divided by 1, so it's not a prime number. But it can't be composite either because it doesn't have more than 2 factors. Okay, so 1 is neither prime nor composite. All right, a prime factor that is a factor, a prime factor is a factor that is a prime number. So when I tell you to prime factor something, I'm saying to get a number and list the factors that are prime of the number. So if I said to factor 16, 4 times 4 is not prime factored because 4 and 4 are not prime numbers. So I would have to actually take 4 and further factor it, 2 times 2 times 2 times 2. We call that the factor tree. You guys probably haven't done that since junior high, because not junior high, I meant elementary. Because I didn't really have you guys do it in my classes. I actually teach you to do the division bar like this, where you start with the smallest prime number that goes into it. If 2 doesn't go into it, you move on to 3. If 3 doesn't go into it, you move on to 4, and so forth. And you divide it. 16 by 2 is 8. 2 continues to go into 8, so 4. 2 because it continues, and then you just keep going. This is the prime number, so you'd list it as 2 times 2 times 2 times 2. When I say to write it as a product of prime numbers, I mean list it this way. If it says to write it as a product of prime numbers, you can also write it with 2 to the 4th power. That is okay as well. That's pretty much it dealing with prime numbers. They're not really that difficult. We've done multiple prime numbers before. Let me look at example 33.2 for you. It says 147 as a product of prime numbers. Okay. So I'm going to write 147 down. And if you're not careful when you look at 147, it looks at first glance like it is a prime number. And there's a few numbers that look prime. 51 looks like it's prime. 91 look like they're prime, but they're not. 51 can be divided by 3. Add 5 plus 1 and you'll get 6. Anytime you can add the digits in a number and it can be divided by 3 or 9, then it's not a prime number. Okay, if you add 9 and 1, though, you get 10. Well, 3 doesn't go into 10, so you might think that it is prime. But alas, actually, 7 goes into 91 13 times. So it is not a prime number either, so don't let those numbers fool you. Now let's use our 3 test here. We're going to say 7 plus 1 is 8, 8 plus 4 is 12. That tells me that 3 goes into those numbers. So in this particular lesson, we're going to take the 2, and we're going to realize that even though it's the first prime number, it doesn't go in there because it's odd. So I can't start with 2. I'm going to start with 3. And I'm going to take 14 and divide it by 3. And I know it goes into it 4 times. 4 times 3 is 12. So 14 minus 12 is 2. I'm going to put the 2 here. If you have a hard time doing that upside down, there's nothing wrong with you doing the math on top like this and coming up with 27. That's okay too. Okay, you can do this if you need to do this. That's fine. If you need to do it this way, just plug it into your factor tree, okay? So I'm going to continue. 4 and 9 is 13. Well, 3 no longer goes into that. It doesn't end in a 5, so I know 5 does not go into it. So I'm going to put a 7. That's the next prime number, and 7 times 7 is indeed the number. So then you would say 3 times 7 times 7, or 3 times 7 squared. Both of those are the correct way of writing it. You have to do what the instructions say, so if it tells you to write it as a product of primes, you have to write it this way. If it doesn't say that, then you can choose to write it either way. The second half of your of your lesson is more on translating equations. And since we covered that in the last lesson, I don't think I need to cover it again today. Don't let it confuse you when it talks about writing the negative first or writing what it does not say first. You don't really have to do that. You just have to translate the equation and then solve it the way I showed you to do yesterday. Okay, guys, that's it. Take care.